Hello today we will discuss about the derivation of electric field due to two infinite parallel charge sheets. So let us start the derivation. Now consider two parallel sheets of charge A and B. This is plate A, this is plate B or sheet B. Okay, so I will label it as A and B. Positive sheet of charge and negative sheet of charge. Positive sheet of charge, negative sheet of charge. Okay, we will calculate the electric field intensity due to these two sheets of charge combined effect. Now, to calculate the combined effect, we have to calculate the effect at the left hand side, in between, and at the right hand side of these two sheets. Okay, and also remember in my last video lecture I have calculated the electric field intensity due to a single sheet of charge, single positive sheet of charge. The result was E is equals to sigma by 2 epsilon naught. Now what is sigma? Sigma is surface charge per unit area. Okay, sigma is surface charge density. Sigma is surface charge density and it is equals to charge per unit area. Okay, so here for due to this single sheet of charge, result will be sigma by 2 epsilon naught. Due to this single sheet of charge, result will be sigma by 2 epsilon naught. Sigma by 2 epsilon naught. Okay, so let us start the derivation for this. Now first we will take the point P. First we will take the point P, that is at point P. What will be the effect of this sheet? What will be the effect of this sheet? In every application of Gauss law, this is one of the applications of Gauss law, I have told you that there is a one basic concept that due to the positive charges, the direction of the electric field will be normal to the sheet, normal to the charge, and outward. So due to this sheet, the direction will be outward, and suppose this is E1, and if due to positive charges the direction is outward, then due to negative charges the direction will be inward. Okay, so due to positive charges, due to this sheet, the direction is E1 towards this direction. And what about this? For these negative charges, the direction will be along these negative charges, towards these negative charges, that is E2. I repeat, due to positive charges, the direction will be outward, away from the positive charges, like E1. Due to negative charges, the direction is along towards the negative charges, that is E2 in this case for point P. Okay, so resultant will be equals to E is equals to E1 as both the electric fields are in the opposite direction, so it will be E1 minus E2. Okay, if due to single sheet electric field is sigma by 2 epsilon naught, so E1 will be sigma by 2 epsilon naught, E2 will be sigma by 2 epsilon naught, so resultant electric field will be 0. Okay, this is at point P. Now what about at point Q? What about at point Q? So please tell me what will be the direction of E1. Yes, the direction of E1 will be away from the positive charges and normal to the positive charges. Away means along this side, away from the positive charges. And due to negative charges, by convention, the direction is towards the negative charges. Towards the negative charges means along this direction, along this direction. So at point Q, again E is equals to E1 plus E2, as both are in the same direction. Both are in the same direction. So we will just add it out. Sigma by 2 epsilon naught, sigma by 2 epsilon naught. So result will be sigma by epsilon naught. E is equals to sigma by epsilon naught. Okay, at point Q. So there is another point towards the right hand side of both the plates at point R. Okay, so again tell me, according to you, what will be the direction of the E1? What will be the direction of E1? That is, the E1 is the electric field due to positive charges. So yes, you are thinking right. The direction is away, away from the positive charges and normal also. Okay, so E1 along this direction. And what will be the direction of the electric field due to negative charges? Towards the negative charges and normal to the negative charges. So E2. So again E1 and E2 both are in the opposite side. So resultant will be E is equals to E1 plus minus E2 is equals to E1 minus E2 equals to sigma by 2 epsilon naught minus sigma by 2 epsilon naught. So result is 0. So it means if I will denote it as E1, as not like E1. Okay, suppose this is EP, this is EQ, and this is ER. So total electric field will be EP plus EQ plus ER, so equals to 0 plus sigma by epsilon naught plus 0, so equals to sigma by epsilon naught, that is the E due to two oppositely charged infinite plates is sigma by epsilon naught at any point between the plates, and is 0 for all external points. At any point within the plate it will be sigma by epsilon naught, and for all other points, external points along this side, it will be 0 for all the external points. I hope so you have understood the derivation and the concept of electric field due to the parallel infinite plane sheets of charge. Thank you. Thanks a lot.